All right, this is part 2. So you have the same task. I've given you 3 examples. I want you to look at them carefully and look at the derivative and see if you can recognize the pattern. And once you think you've got it, come down here and try and figure out what the derivative of these bottom 3 functions might be. So please pause and do that before you continue. And then I will walk through them and tell you what I want you to notice and what I got in the bottom 3. All right, so what I notice is that every function over here has sine as the outer function. They're all composite. It's a function plugged into a function, and it's always a function plugged into sine. The inner function, kind of like last time, is changing. When I look at the derivative, what I notice every time is that there's a cosine. And again, I bet we could kind of reverse engineer and say, okay, it's because we were having the derivative of sine, and that's cosine. I also notice that the inner function stays the same all the way through. And then once again, I have this funny extra piece out in parentheses after that cosine function. So if I start looking through and thinking about where that's coming from, the derivative of 3x squared minus 7x is 6x minus 7. The derivative of e to the x times 5x cubed requires a product rule, and that's what we're seeing out here. We're seeing the second multiplied by the derivative of the first, plus the first multiplied by the derivative of the second. And then in this last one, the derivative of 1.2 root x, we would think of as 1.2x to the 1/2. When you drop the 1/2 down in front, you'd get 0.6, and then the new power would be x to the negative 1/2, which is the same as root x in the denominator. So if we are getting that, down below, I would say that the derivative of sine of 7x to the 17 minus e to the x would be cosine. I would leave the inner function exactly as it appeared, and then I would multiply by the derivative of the inner function. So 7 times 17, I think that's 119. You might want to check my arithmetic. And then the new power will be 16. Minus the derivative of e to the x, which is e to the x. For the second one, I'll start the same way. The derivative of sine is cosine. In this first part, I'm supposed to leave the inner function alone. And then I'm supposed to multiply by the derivative of the inner function. This time the inner function is a quotient, so we'll need a quotient rule. I'd need 5x to the 4th squared. And then on the top, I would need 5x to the 4th multiplied by the derivative of e to the x, which is still e to the x, minus e to the x times the derivative of 5x to the 4th, which is 20x cubed. All right, and once again, the last step here is to generalize what we're seeing. So what I'm seeing is that if I have sine of some function, the derivative will be cosine of that exact same function, multiplied by the derivative of my inner function. So we're building up like baby special cases of the chain rule as we go here. We haven't gotten the full chain rule, but we're starting to see bits and pieces.